So up next, we'll be talking about multiple alleles, patterns of inheritance. So this chart shows the 4 different types of blood type. There's A, B, AB, and O. When does multiple alleles, patterns of inheritance, occur? Well, it occurs when there are 3 or more alleles available for a gene. It can't be 2 because then that will be too simple. It has to be 3 or more. So we'll start with the blood types. The homozygous dominant would be AA or BB. This is the first and second column or rows of the chart. It says A and B, and when it's put together, AA or BB, it is homozygous dominant. The homozygous recessive blood type is OO. And blood type AB is considered codominant, while both blood types A and B are dominant over the O blood type. It's considered codominant because it's a mix of both A and B. This photo is by Socratic.org. So up next, I'll be solving a multiple alleles problem for feather color in pigeons. So the first allele is BA, which is the dominant allele, and it equals ash red feathers. So they're about this color. The recessive allele is lowercase b, which represents chocolate feathers, or the color I'm highlighting it with. And the third allele is a kind of a mix. It is recessive to the ash red feathers, or BA, but it is dominant to the chocolate feathers, which is B, and it is the blue feathers, so this color. So let's now go on to fill out the possible genotype-phenotype combinations. So the first genotype is BAB. So that would be ash red feathers to blue feathers. So the phenotype would be ash red, and it would be heterozygous. It's ash red because the BA is dominant to the B. Up next would be BA lowercase b, which would be ash red to chocolate. It's once again ash red feathers because that is dominant to chocolate feathers, and it would be heterozygous again. Up next is capital B lowercase b, which would be blue feathers to chocolate feathers, and it would end up being blue. This is because the capital B is dominant to the lowercase b, so blue feathers are dominant to chocolate feathers. This would also be heterozygous. Up next is capital B, which is blue again, and it's homozygous because it is both blue, so it would be HMZ. Up next is lowercase b, and that would be chocolate because it is homozygous, so there's nothing dominant to it. It's 2 recessives next to each other. So this would also be homozygous. And next is BABA, and this is ash red because it is homozygous to ash red. And it is HMZ because it is 2 ash reds. So using a Punnett square, we are going to cross an ash red heterozygous male who carries the chocolate allele and a blue heterozygous female. So what we're going to do is if it is an ash red male, it has to have the BA. It also needs to have the lowercase b because it's carrying the chocolate allele, and a blue heterozygous female. So if it's blue, the only way it can be heterozygous and blue is if it also has a lowercase b, because the blue feathers are dominant to the chocolate feathers, but they are recessive to the BA. So let's solve this. It would start with BA, B, BB, BB, and BAB. So the final combinations are it's BAB, which would equal ash red, BB, which would equal blue, BA lowercase b, which would still equal ash red because it's dominant, and lowercase b, which would equal chocolate. Hope that helped. Thank you.